I didn't notice that it started recording already. Well, hello, how are you? Hope everyone is well. So this lesson or this recording is for Wednesday the 18th. This is another virtual day due to day 2 of the ELA testing. So again, you are encouraged to stay home, and remember, if you go to school, you will need to be in a holding place until 11:30, and then you after lunch you just go regular classes. Okay, so today we are going to do topic 6 and 7, congruents versus similar triangles. We will just talk about briefly about each one of them. This is the last two topics of that section, which means that Thursday and Friday I will review for the section, the USA section on 3 and 4, on section 3 and 4, and then after Thanksgiving break we will do a brief review on that Monday when we come back, and then you will start the test on Monday and finish it on Tuesday. I didn't want to do this, but because they canceled one entire day of the school because of the hurricane or the tropical storm that happened last week, things got pushed back a little further. So you are encouraged to study over the Thanksgiving break, or if you can't, it's all right. Just refresh your memory in that weekend before. Homework 7 is assigned. It is on IXL. There are 2 standard of homework 7, so make sure you submit 2 screenshots. You need to earn 80 or higher. Some of you are submitting screenshots with lower than 80. Okay, if you have lower than 50, then I can't give you credit. That means you practiced 1 or 2 questions. But if you have anything 50, 60, 70, you can get probably a D or a C in that assignment. You need to do both of them, both standard, both screenshots. Make sure the screenshot is nice and big, coming from the entire screen, so I can see your name right there on that corner, your score, and the skill you're practicing. Assignment 9, which is quiz number 1, deadline has been extended until this Friday. Okay, I can't stress hard enough. Some of you did, so now we have about 75 participation, 75 students out of 120. So still have almost a little. We need some more. 45 students. That's a big number for a quiz not to be taken, but I will not be able to extend it over the break. This video is recorded and will be posted to Delta Math right after I finish recording it. Remember to submit a screenshot shows that you have completed 100% of watching the video to get the 20-point credit for this particular assignment. All right, let's get started. So again, as I talked about, we're going to do congruent versus similar. I put a big picture in there to show that what congruent figure looks like and what similar figure looks like. So the congruent figures are just figures that are exactly the same in size and in shape, which means that all the sides are equal to each other and all the shapes are the same. So like a triangle is congruent to a triangle, or a square congruent to a square, rectangle to a rectangle, and so on. In the similar figures, they are not the same size, but they are the same shape, which means that a square can be similar to another square, but it's smaller in size. But it can't be similar to a triangle or similar to a circle. Okay, so that's something you want to keep in mind as you're looking at the difference between congruency and similarity. Okay, so let's talk about now, because we're talking about polygons, so this will be majorly polygons, the difference between congruent figures and similar figures. First, congruent figures will have this symbol right here, which is the equal sign with a little squiggly line on the top of it. That means congruent. In the symbol of the similarity, it's just a squiggly line. That's all. Okay, congruent polygon would have the same number of sides and the same number of angles. Same number of sides and same number of angles. Also, similar polygons have the same number of sides and angles, but not necessarily the same measurement, which we'll talk about next. Congruent sides of corresponding sides of polygons are congruent. Like I said, the entire number of sides for a square would equal to another square. So they must be exactly the same shape, exactly the same measurement, the same length. But in similar polygon, they're not the same. So I can get a bigger square and a smaller square. They're similar, but they're not the same in measurement, which means that the corresponding sides must be proportional, okay? Which means that they either get bigger or smaller by the same scale factor, which I'll talk about it next. In congruent polygons, we can see that corresponding interior angles of congruent polygons are congruent. So the angles are also congruent. And then also the angles for the similar polygons are also congruent. So whether it is, so the main difference between similar figure and congruent figure is that in a congruent figure, the sides are congruent, but in a similar figure, the sides are similar, which means they're proportional. And the angles are equal in either situations. So that's something you should, just the difference of how they actually look. You see how the triangles that are congruent in blue right here are all the same triangles. No excess measurement or anything. All of them are the same number of sides, same number of angles, same length of each of those sides. But in a similar figure, you can see the triangles are all look like right triangles, and they are similar, which means that they are either enlarging by a factor or reduced by a factor. They have to be dilated somehow by a specific factor. But if I am able to measure each of these angles right here, I'll find that the angles are the same. Okay? Another shape of how similar versus congruent would look like. All right, so let's take a look at this. Will a rigid or non-rigid transformation produce congruent figure? You probably can tell that a rigid transformation, that means it preserves the size and the shape. Okay, no change in the size or the shape. But the non-rigid, there is a change in the side, in the size of the shape. No change in the shape. The figure itself will remain the same, but the actual size might get smaller or bigger. Okay, I'm referring to dilation, which means that rotation, reflection, and translation will give a rigid transformation. That means the pre-image and the image are congruent, but the non-rigid transformation will not give a congruent figure. It will give similar figure. So which one of these? Rigid transformation, non-rigid transformation, rigid followed by non-rigid, or it doesn't really matter? Well, to get congruent figure, you must have rigid transformation. If you have a dilation, which is the only non-rigid transformation, then you have similar figure. So the answer should be the first option. Will rigid or non-rigid transformation produce a similar figure? Now, as you can see, these are check boxes. So you know what that means? It means that you can choose more than once. Well, will the rigid give you a similar figure? Or the non-rigid give you a similar figure? Rigid by non-rigid will give you, or it doesn't matter. Well, we already know that non-rigid will definitely give us a similar figure, which the dilation. Well, the rigid followed by non-rigid. Well, if I did a transformation then of like a rotation, then I did a dilation right after it, well, that will give you similar figure, right? So that also will be the case. So it can be non-rigid only, and it can be rigid and non-rigid at the same time. Use the definition of congruence in terms of rigid motion to prove that rectangle ABCD is congruent to rectangle A prime, B prime, C prime, D prime. Now, please remember, congruency means that you have the same shape, same size. Same shape, same size. So I will look at AB and then I'll look at A prime, B prime. So the size, or we can see here, AB is only 2 units, we can count. A prime, B prime is 2 units. And then BC is 1, 2, 3, 4 units. Then B prime, C prime is also 4 units. DC is 2 units. CD prime is also 2 units. And then A prime, D prime is 4 units. Then AD here will also be 4 units. Notice that corresponding sides are having the same exact measurement. Corresponding side have the same exact measurement. So you see how it's 4, 4, 4, 4, and then we have a 2 and a 2 and then a 2 and a 2. These are corresponding. Okay, so for me to write this down, I'm going to write down that rectangle A, B, C, D is congruent to rectangle A prime, B prime, C prime, D prime. All right, since all the sides are equal. Since all corresponding sides are congruent. Just get something that's you can see. Are congruent. Okay, we can also refer to this as that AB actually corresponds with A prime, B prime, A prime, B prime. So that would be congruent to A prime, B prime. And then BC is congruent to B prime, C prime. And then DC is congruent to D prime, C prime. And then the last one is DC, and then we have AC. Okay. You can type in the answer that you want, but this is just a general idea of how it looks like. This right here, what a congruency statement looks like. And this right here is the corresponding sides of the congruency. We don't have to write the angles because it's a rectangle, but in a triangle or anything like that, then it's good to write the corresponding angles too, but they should be equal. All right, so let's move on. And it doesn't look like it's gonna let me move on. So we can just say that A, B, C, D congruent to A prime, B prime, C prime, D prime. I know I didn't do a good job writing all of these, but you can write, I already wrote it for you. I'm trying to save time on your video so I don't have to sit here and watch for too long. Take a look at an example. It says, in the graph, triangle MNO is the image of triangle BAC after rotation of 270-degree counterclockwise about the origin. Which of the statement below are true? Select all apply. Remember, when it says select all that applies, that means we have multiple select, okay? We have multiple select, so we have something like that. A multiple select, okay? We have a multiple select. So let's take a look at this right here. So which one is the image of the other? It says MNO is the image of BAC. So MNO is the image of BAC, and notice the arrangement of the figure. Okay, it says 270-degree counterclockwise, so this is a rigid transformation. This is a rigid transformation. And rigid means that the size is the same, the shape is exactly the same, all angles are the same, all sides are the same. So let's read. It says AB is congruent to ON. AB is congruent to ON. Is this true? Is AB and ON are congruent? Well, AB isn't corresponding with ON. So let me put the marking in, that might help. So AC, it corresponds with ON, right? And then AB is corresponding with MO. And then CB try 3 marking, will be corresponding with MN. So the corresponding must be congruent. The corresponding must be congruent, but if they're not corresponding, then they can't be congruent. So AB and MN are not congruent. So they're not corresponding, they're not congruent. We can't use it. Then it says BC is congruent to MN. BC, right here, is congruent to MN, is congruent to MN. BC and MN, is this true? Yes, they are corresponding, they are congruent. So the second option is correct. Angle B and angle B is right here, and angle M is right here. Are these corresponding angles? Yes, then they are congruent. N and C, N and C, are these corresponding? Yes, they are. N and C are corresponding, so it's true, they're congruent. Then it says ACB, ACB is congruent to MNO, to MNO, MNO. ACB is congruent to MNO. Let's see, this goes down. It says ACB is congruent to MON. If you look at the figure, it just has to be in the same order, but the two triangles are congruent. So all of these options are correct. So this is correct, 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 correct. This one just the only one that isn't, because AB and ON are not corresponding. So be careful with that, okay? All right. Based on the two similar squares above, name the property of a similar polygons and give the justification that proves the figures are similar. So the only way to know whether these figures are similar or not is really by looking at the scale factor. Okay, so it wouldn't matter in this case where to go from where, because we can say that ABCD is enlarged and created EF GH, or we can say that EFGH reduced and created ABCD. As long as you're moving from one to the other consistently, you're okay. So first I need to know, they're definitely similar. I can see that because they're small. Okay, we see one has change in the size than the other one. We also see that there's a change in the size, but there's no change in the actual shape. They're both squares. So let's go ahead and count what AB is, and corresponding with AB should be EF. So AB is 1, 2, 3, 4. So this is 4 units. And then here we have 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is 8 units. Okay, and then because it's a square, you probably can imagine that all the other 4 should be 8 here. You can count them. And then here, all these should be 4. Okay, so can we tell can we find the scale factor here? So first I'm going to write the scale factor right there. So that's K. Okay, scale factor is new over old, but since we don't know which is which, just go 8 over 4 or 4 over 8, it's okay. Normally it is given to you, but this is just for instruction purposes. So it's TU, it's 2. And we can see that if I divided any of these over 4, I will get 2. So it is a scale factor of 2. So that means these are similar. So the next thing would be is that I know that the angles are the same. Can you see that? But the size of the figures are not the same. So that means I'm going to write the proportion here. So I'm going to write that AB is proportionate to EF equal EG or FG is proportional to BC. You see, I'm writing corresponding sides, okay, equal to GH corresponding to CD, and then finally HE corresponding to DA. That's equal to that scale factor, which is 2. Okay, if I switched them and I said EF over AB, then I must switch the scale factor as well. So it would be 4 over 8 rather than 8 over 4. Okay, so that's really what I mean. So any two sides are proportional with the same scale factor. So I can eventually take any of these pairs outside and set them equal to 2, like this. AB over EF equal to 2. And then similarly, the other ones as well. Okay? Now, next thing about similarity too is the angles. So it is angle A is equal, congruent to angle E. So corresponding angles are congruent, but corresponding sides are proportional. Okay, that's really the difference between these. I can keep going with the angles, but you can tell that all of these 4 angles are equal to 90 degrees. They'll be equal to 90 degrees here as well. And it does apply when it's a triangle. It does apply with any kind of polygon. This just looks very clear because it's a square. Okay. So I can say that A, B, C, D squared is similar to E, F, G, H. And I'm going in the same order I did A, B, C, D. I'm going E, F, G, H. Okay. All right, that's really it for this particular problem. I just wanted to show you the difference between all of this. And I can write down A, B, C, D is going to be similar to E, F, G, H. E, F, G, H. And you can write everything else that you want to write in this particular one. All right, determine whether the polygons are similar, and if they are, we're going to find the scale factor from A to B. Okay, we're not going to write the similarity statement. It really happens only when we're dealing with triangle, which we have an entire 3 sections on triangles. I'm not going to worry about that. So it is scale factor, it already specified the scale factor. It is from A to B. It is from A to B. Okay, this means that A became B. So this is our new, and that's our old. Okay, be careful when you do that. To find the scale factor, you have to talk about, so K equal corresponding sides. So I'm going to try to use color coding. Maybe like bluish or blue. Blue sounds good. All right, so 6 should be congruent to, corresponding to, 6 should be corresponding to 2.4. And 3.2 is corresponding to 8. And then 10, which is a slanted line, should be corresponding to 4. So I try to underline, single line, double lines, and circle. So in order to do K should be new over old, as we talked, new over old. Okay, let's see if each one of these proportional will give me the same scale factor. So first I'm going to do 6 over 2.4. And if I divided 6 over 2.4, what would I get? 2.5. Then 8 over 3.2. 8 over 3.2. Same thing. It would be 2.4 as well. And then 10 over 4. You can try it. 2.4. So the scale factor is 2.4. And we can see that from A to B, we can see that the triangle A slightly enlarged to become triangle B. So yes, the scale factor is greater than 1, which means it did make an enlargement. So yes, they are similar since all the scale factors are the same. So yes, they are similar, and they have a 2.5 scale factor. I do want you to try the next two on your own. So let me see if I can. I don't want to do these for you. I want you to try them on your own. The key here is actually try to understand when you look at these right here to go from A to B, what are the corresponding sides? You can probably tell that 12 and 9 are corresponding, and 8 and 6 are corresponding. And we have 4.5 and 6. And again, new over old, and we talked about that. We're going from A to B. That means B is new and A is old. Okay? Now, I'm not going to move forward. I'm going to go share this instead. And go back here. And then see if I can skip those really quick. I know I'm unable to skip for some reason. All right, now we can come back here. This question is very, very important because you have a similar one to it on your next test, and I highly recommend understanding it. It's a multi-select question, so this is in your next test. You have something similar. The larger popsicle is a dilation of the smaller popsicle. So now, just by looking at this, we have a larger popsicle, we have a smaller popsicle. Which one is the new and which one is the old? Select all statements that are true. The larger is the dilations. That means the larger is the new. So this right here is our new. The larger would be our new, and then the smaller would be our old popsicle. And since it's a larger to small, that means the popsicle got bigger. So we have an enlargement. So your scale factor should be bigger than 1. So it says, and I mentioned that before, when you're looking at all of these options right here, when you have a multi-select, you really need to look into each option that you have and find out whether it's right or wrong. Because you miss one of the options, you get the entire question wrong. So first, the scale factor of the dilation is 3/2. Let's find the scale factor. We know that the larger is, so this is our new, this is our old. Our K should be new over old, which is 3/2. So that's true. The first option is correct. First option is correct. Point L is the center of dilation. So look at this. Here's point L right here. I know it's hard to imagine, but imagine yourself sitting right there, standing at point L, and taking a picture of the popsicle, the smaller one and the bigger one, right? Your center of dilation is where you are zooming in towards that. Your two figure must be within the radius or within the diameter of the point, the center of dilation. That's why L is the center of dilation. I briefly touched on it before, but here it is. The point of the center of dilation is the center where both of the image and the pre-image must be within the radius of that particular point. Okay, so this is correct as well. Is LOV similar to LEY? LOV is similar to LEY. LOV similar to LEY, to the larger one, to LEY. Is that true? It is true because dilation always results in a similar figure. They always result in similar figures. So that's also a true statement. 3LY equal to 2 means LV equal to 2LY. LV and LY. So we are looking at LV and we're looking at LY. So what is the scale factor, or what's the proportion between LV and LY? So here's LV, here's LV, and here's LY. which is the smaller of this and the bigger of that, that's equal to the scale factor, right? This is from the smaller triangle to the bigger triangle, so it should be 2/3. It's the flip of the scale factor we're given because it's going from bigger to smaller, so it should be 2/3. Okay, now if I cross multiply, so I get these multiplied together and these multiplied together, I'll get 3ly equal to 2, look at that. I meant to say 3lv should equal to 2ly. We cross multiplied. Okay, so this is nothing more than the actual scale factor, okay, manipulating the statement. Okay, all right, so that option is also true. The 3lv equal to 2ly. The last one, it says LO over OE, and let me just close and just erase that. LO over OE, LO over OV, over OE, sorry, over OE, which is this, equal to OV over EY. Now, the second two are definitely corresponding. We can definitely see that second half right here of the proportion, they're definitely corresponding, okay? Because that's the larger and the smaller popsicle. But if you look at the first option, which is LO and OE, these are not corresponding because OE is not really a side of the bigger triangle, okay? So for this to be more accurate, it would be LO over LE, which is the larger hypotenuse, the larger side. So the last option is incorrect, They wrote the proportion inaccurately. Okay, so it's only the first four. All right, I am done. This is all about that lesson. Just submit a small, let me know, how do you feel? Because there are so many information on that next test on transformation and some of the similarity ones that I'm including in your lesson. So it's not the first time you're going to see them on your test. Okay. And again, make sure you are watching 100% of that video so you can get credit. And if you have any questions, you always send me an email. Okay. Remember, Wednesday, the 18th is a virtual day for the second day of testing for juniors and some seniors. Okay. Encouraged to stay home. All right. Until I see you next, stay well. Bye.